A laser blanking line cuts parts straight out of a moving coil of steel, with no sheets, no forklift, and no skeleton left over. By the end of this, you will know how the strip is fed, why the leveler matters more than the laser, and the three things that actually stop one of these lines overnight. Start with why coil at all. A steel mill sells you a coil. Anything else, a service center has already uncoiled, leveled, cut to length and stacked for you, and that handling is priced in. Coil is the cheapest form the same steel comes in, and on a blanking line, it is also the least handled. The line starts at the decoiler. It grips the coil on an expanding mandrel, and a powered pinch roll peels the leading edge off and threads it forward. The decoiler does not just unwind. It breaks, holding back tension so the strip stays flat and controlled instead of springing loose off the coil. Then the part almost nobody thinks about, the leveler. Coiled steel remembers its curve, and it also carries uneven internal stress across the width. A leveler runs the strip through a nest of small offset rollers, bending it back and forth past yield, so the stress is worked out and the strip leaves genuinely flat. That matters because a laser cuts what you give it. Feed and strip with locked-in stress, and the parts move as the cut releases it. Edges lift into the nozzle, tolerances wander, and small parts can tip out of the strip. Most blanking line problems that look like laser faults are really flatness problems. Next comes the loop. Between the leveler and the cutting zone, the strip is allowed to sag into a pit or a free loop. That slack decouples two machines that will never agree. The decoiler and leveler move the strip in surges. The cutting section wants smooth, precisely metered motion. The loop absorbs the difference. Now the strip advances in steps into the cutting zone, and the fiber laser head works over that window on a fast gantry. On the most advanced lines, the head tracks the strip while it keeps moving, so the beam follows a path that is the sum of its own motion and the strips. Cutting never stops for the feed. The payoff is nesting. Cutting sheets means nesting inside a fixed rectangle, and whatever is left is skeleton. On a coil, you nest along a strip with no end, so parts interlock across what would have been the sheet edge. That is real yield, and on a high-volume part, it is the whole business case for the line. At the exit, parts are separated from the web, taken off by vacuum grippers or a robot, and stacked. The remaining web is chopped by a scrap shear and dropped into a bin. Downstream is where lights-out lines usually fail, because a stack that grows crooked or a part that lands half on a pallet stops everything. So what really keeps it running unattended? Three things. Consumables at the head, so an automatic nozzle changer and a protective cover glass that gets swapped or monitored rather than slowly clouding over. Clean cooling and clean gas, because a chiller alarm or a dirty assist gas ends the shift. And material joins because a coil eventually runs out. Which is why lights out is a materials handling achievement, not a laser one. The laser is the reliable part. The unattended hours come from leveling, tension control, part removal, and consumables. Get those right and the line runs on its own. Next episode, the three things that quietly kill laser uptime: the chiller, the optics, and the nozzle.